Hello and welcome back to AP Environmental Science. Today I want to talk about waste and our disposable society. Although whether we have a disposable society or not, we have waste, and we know there's all kinds of waste. We've already talked about water waste issues off of industrial processes. We've talked about feedlot waste. We've talked about human waste in terms of sewage and stuff like that. Today what we really want to talk about most though is solid waste and hazardous waste. We also want to talk about waste prevention, reduce, reuse, recycle, and then we want to talk about what we actually do with the massive quantities of waste that we produce. So first let's talk about solid waste. The US actually generates more solid waste per capita than any other country. It's about 4 to 5 pounds per day, and this is unsurprising. We've talked about this, but we are not alone. That number happens to be just a little bit higher, but there are lots of other countries that are really catching up, and that has to, like China for instance, that has a lot to do with rising affluence and becoming consumer societies. Now we're going to break our solid waste down into two types, municipal solid waste and non-municipal solid waste. Though non-municipal solid waste is actually the bulk of the waste stream, and that is going to be all of the stuff that's generated by industry, agriculture, drilling and mining, construction, all of that kind of stuff. And so we're going to focus on the municipal solid waste because it's what we usually think of, but I want you to understand that just like in water issues, the bulk of the water problems are not actually caused by residential or even city and commercial water users. I mean, it really is about these other processes that we don't have a lot of control over. And again, I want you to be familiar with them, but we're going to focus on municipal solid waste because it's stuff that we can control to a certain degree. At least we can control our own. So we talk about resources. Look at this. This is the mining and oil and gas production waste. I mean, that's 75% of the waste. Then you have agriculture's 13, industry's about 10, and here's our little municipal solid waste at less than 2%. Now, sewage sludge is going to be included in that, though, because that happens to be a municipal thing. So as we've been talking, and we're talking about landfills, it's actually going to be this almost 3% that you have going on here. So, right, the big question is what actually happens to all of this stuff. All right, so here's your first mini quiz question. The problems associated with municipal solid waste is or are: we continue to produce more of it all the time, with the exception of coastal areas. There's plenty of land for landfills in the US, thus there's little incentive to reduce waste pollution. It is a mixture of materials, including some that are hazardous. Because it's mixed up, it's often difficult to separate for reuse or recycling, or all of the above. Well, it turns out that, well, the first one is obvious. That's definitely true. I mean, we produce more and more of it all the time. Having said that, though, we like to think that with urban sprawl and all of this stuff that we don't have a lot of room, and in many cases we don't. I mean, we don't have a lot of places to go as we start spreading out. Having said that, though, we do, right? And right now, even though landfills are filling up and they're closing, and it's hard to find space for more landfills, it's hard to find space for more landfills close to cities that produce lots of waste. There's actually lots of land that is out there that may be used for something else that we could, if we wanted to, convert into a landfill. And so that pressure to reduce waste production because of landfills, one, you've got the out of sight, out of mind issue, and two, it's not as pressing as it could be for people, right? Even though it might ought to be. So it's a mixture of materials that are hazardous. Yeah, that's a real problem. Some of the stuff that's in there should not be in there. It should actually be going someplace other than where municipal solid waste goes, and we'll talk about that in the second part of this conversation. And then because it's all mixed up, a lot of times it's really difficult to separate for any other usage, right? So whether that's reuse, composting, recycling, whatever. So all of the above for these are real problems. So we talk about solid waste. What is actually in it, right? Well, when we talk about what's actually going to landfills and stuff, I found this. This is for Texas last year. We actually had almost 200 municipal solid waste landfills. And as we're going to see later on, over half of waste is actually sent to a landfill. So that's an interesting thing. Out of what goes into the landfill, 2/3 of it is municipal solid waste, and then we have brush and yard waste and all that kind of stuff, and then we have the construction and demolition waste, and they're about equal, and they all go to landfills. But when we look overall, municipal solid waste by material, what is it? Still, a good portion of it is paper and paperboard, right? So cardboard, stuff like that. Stock, cardstock, all of that. That is interesting because we know that we can recycle. Now, this is before recycling, but we're still using a lot of paper, I think is the point. So that's kind of an interesting thing. Anyway, then we look at it. Ooh, here's that food waste, right? Remember we talked about 40 to 50% of all food is wasted. A lot of it goes in the trash, right? Yard trimmings, plastic, also recyclable, metals, recyclable, rubber, leather, and textiles, maybe reusable, not recyclable, wood, recyclable into paper, glass, recyclable, and then just other random stuff. All right, so what component of municipal landfills is the fastest growing solid waste problem in the US and is also a hazardous waste problem? Well, for those of us that have dealt with disposable diapers, it's really tempting to say that. That is not actually an issue, but I will say that disposable diapers are a real problem. They do not degrade, and there are lots and lots and lots of them. You can imagine a newborn, for instance, is going to use 12 to 16 diapers per day, right? And so now you're talking about all these disposable diapers piling up in landfills. They can't be reused. They can't be recycled. Now, a lot of people would say, hey, well, instead of using disposable diapers, why don't we use reusable diapers? Water. They have to be flushed into the toilet and then they have to be washed. And so now you're using lots more water than you would. So both of those have issues. Diapers, unfortunately, are a real, real environmental problem. But that is not the answer to our question. Motor oil is a straight up hazard, and it's not really a fastest growing solid waste problem. I mean, cars are cars. Number of those increases consistently, but it's not becoming this sort of epidemic of trash. Plastic bottles, straight up recyclable, also not hazardous, not toxic. The answer to this question is electronics, right? Electronics have heavy metals. They have all kinds of things in them that are toxic, and when they go to landfills, those things leach out, and they really need to be disposed of properly. And we'll come back to talking about that when we get to the hazardous waste section of this. Okay, so how do we dispose of stuff? The big area, literally, of disposal is going to be the sanitary landfill. We also incinerate trash and then we recycle. And recycling, fortunately, is about a third. It could be more, right? It's great that it's not less. So that is a huge plus. We're getting better about recycling. Having said that, you can see that still over half goes to sanitary landfills. And we'll talk about that in just a second. And we look at that same kind of breakdown, you can see that it's not really changed a whole lot in terms of the amount that's being landfilled. It has a little bit. It's dropped off here in the last 20 years. But what's really happened is recycling has become much more popular. So to deal with the massive increase in waste, right, it's great to see that recycling has really taken the bulk of that. And that's a nice thing. All right, so sanitary landfills, we don't just dump stuff anymore. It is really important that these are contained, and sanitary landfills and secure landfills, which we'll talk about in a minute, are engineering marvels, really, if you really look at them. First of all, there's going to be a liner and a leachate collection system. So the liner is going to prevent any yucky stuff from getting into the groundwater, and then the leachate collection, remember, it's going to rain, and you're going to have groundwater that comes into the actual landfill area itself. That is going to trickle through the trash, it's going to dissolve and pick up stuff, and that water is really contaminated, especially if you have stuff that shouldn't be in the landfill. So this runoff, if you will, it's called leachate, of the landfill is problematic, and so we have systems built in to actually collect that and take that so it can be stored or treated, and that's really important. Most landfills nowadays, especially if they're capped, have a methane gas recovery system, and as that trash is anaerobically decomposing, you can get this methane off of it, and you can actually redirect that methane so you can generate electricity or heating for the buildings that actually surround the landfill. And every day the trash is compacted, it's covered up. Unfortunately, these are so well compacted and so well sealed. That's a great thing, but the downside of that is what it means is that stuff in landfills actually never decomposes really. There are archaeologists and anthropologists right now that will take cores of landfills and they can actually read newspapers from 1950. It really is a way to preserve stuff, and that's probably not exactly what we want with trash. We'd really like it to start breaking down, and it doesn't, so that's a problem. But anyway, so there's a little bit about sanitary landfills, and then here I've put in here the advantages and disadvantages of landfills. Check these out, and then we're going to watch a little video in class that actually shows you a landfill and how it works. Okay, so which of the following is not an environmental problem associated with properly managed sanitary landfills? Populations of vermin, groundwater contamination, leakage and combustion of methane, incomplete decomposition, and settling of material. So some of these things most of these things actually are problems associated with sanitary landfills. Even when they're properly managed, you can have problems. One of the things that is not a problem of a properly managed sanitary landfill is populations of vermin. That we cover up the trash every day, and so vermin don't come. Having said that, though, you can still have problems with groundwater contamination. What if you get overflow and that runs off over the liner? The leakage and combustion of methane, those collection systems are great, but they are not able to collect the methane everywhere. We already know that things don't compose in landfills, and the material settles, which can cause voids and gaps over time, and you crush it in. But one thing we don't have is populations of vermin, and that is good. All right, so what are some special issues? Plastics, these are chemically stable. They don't break down. Some plastics can take up to 10,000 years to decompose. Much of this is from packaging. A lot of that stuff is going into landfills, partly because some plastics are still really hard to recycle. And then lots of people don't recycle. The other thing that's a really big problem are tires. Tires have two problems. One, they have toxic materials in them, and they can't be recycled. They can't be recycled easily. The second thing is that they take up space. I mean, if you look at a tire, it's got a big hole in it. So they actually take up huge amounts of space in the landfill. And you don't get the good, efficient compaction of the trash. So unfortunately, there's not a lot you can do with tires, and there are lots and lots of tires out there. They can be incinerated and they can be shredded. The problem with incinerating tires is the pollution. They are dirty. I mean, they put off all kinds of stuff. Now, having said that, though, shredded tires can be turned into playground equipment, trash cans, garden hoses, carpet, roofing materials, all kinds of things. And about a third of tires are currently recycled, but we could definitely recycle way more tires. So there are some uses. So there are a couple of things that are problems. Back to the plastic really quickly. Plastic sacks. Those have only been able to be recycled fully recently, and now we can make decking material and stuff. But as we get better at recycling, some of these things will cease to be problems. But we do have some of these things that are just problematic in landfills. All right, so getting back to those incinerating those tires, we actually do incinerate trash, and the really good thing about this is that it reduces volume, and we do have land problems. Even though right now those land problems are not pressing, one of the big problems is NIMBY, not in my backyard. Nobody wants a landfill in their backyard, right? Not in my backyard. And so it is a concern about where to put new landfills, even though there's space available for them in many places, or at least, outside. And sometimes now you're starting now you're starting to talk about trekking trash really long distances. So incineration is a really good way to reduce the volume that's going into landfill because only the ash is landfilled. And so you could actually reduce the volume by about 90%. The other great thing about incineration is that it produces heat that can make steam to generate electricity. And this process is called waste to energy. It is called waste to energy. And it is something that lots of people are actually using, this idea of, hey, we can kill two birds with one stone. We can reduce the volume of solid waste and we can produce electricity from it. Great idea. Which of the following, however, is a drawback of the combustion of municipal solid waste? Burning waste means less material must be placed into a landfill. Trash collection procedures don't have to be changed. Toxic and hazardous substances can be appropriately treated in fly ash and bottom ash. Burned waste can be converted into electrical energy. Combustion facilities for energy require a continuous supply of municipal solid waste. Okay, well, first of all, burning the waste does mean less material goes into a landfill. Win. Yay. Trash collection procedures, you just pick up trash. You don't have to add anything. Yay. Now, toxic and hazardous substances are a problem in incineration. Hopefully they can be separated out in the beginning, but even if they can't, a lot of times that stuff stays in the fly ash, and you can treat the effluent, but there is a problem sometimes with toxic and hazardous gases off of incineration, but that's something that has to be dealt with. This is not considered a major drawback because you can deal with it, all right? Burned waste can be converted into electrical energy. Win, yay! Now here's the catch though. If you're making energy with trash, you have to make trash. This actually incentivizes the production of trash. And that is a problem, right? And so it's sort of an unintended consequence of this really great idea to deal with this problem. Why would you want to recycle? Why would you want to reduce? You want electricity, don't you? Right? You want heat, don't you? So make trash. So that's kind of a problem. All right, and so again, I've put in this slide of, what the advantages and disadvantages of incineration are. I do want to point out that you have less waste to dispose of. That's the really big plus, but also you'll need less coal, right? And so you can mine less coal, you can burn less coal. It's a big plus there. And that's not on the sheet. All right, let's talk about composting. Composting in some ways is kind of like a type of recycling. But basically, if it's organic, you can compost it. Again, you're going to reduce the volume in landfills, makes an excellent organic fertilizer if you're trying to switch off of inorganic fertilizers, and it can be sold or distributed to the community for profit. If the city did this, they could actually sell it, through stores or whatever. If private companies did it, they can sell it through stores. You can make money, you can make jobs. And then here's just a little bit about how a composting bin works. There's a nice little picture for you to look at. All right, so the best thing to do though is to prevent waste to begin with. There are ultimately three goals when it comes to waste. The first one is reducing the amount of waste, preventing the waste from ever even becoming a problem. Once you do make a product, you can reuse those products. Again, it's a no waste kind of situation. And then the last one, which takes more energy, is to actually recycle it into something else. So if you're looking at in terms of energy usage, reduce is the least amount of energy because you don't make anything, you don't have waste. Reuse it, you make it, but you don't have the energy of converting it into something else or disposing of it. And then recycling, you make the product and you put energy in to recycle it, but you don't have the waste. So that's kind of how that goes. All right, so reducing waste, when we talk about the reduction, we're talking about a couple of things. Source reduction is the big thing, right? Decrease the stuff that's being manufactured. Decrease packaging, right? Decrease all of those things. And then also dematerialization is a thing, right? And you can think about things getting smaller, lighter, having less material in them. So first, products are made that use less materials to make them or whatever, but you get the same product. Maybe you have less packaging, right? That's the source reduction. Dematerialization is a specific change in technology that actually changes the product itself, right? And then there's the energy, the 3 R's I just talked about. And then I put this in here so you can kind of see what are some comparisons in terms of what we do with waste. And this thing happens to be in support of a process called anaerobic digestion, which we talked a little bit about when we talked about water treatment. And so you can see, you can compare that in dealing with some waste to our standard composting, waste energy, which is incinerating and landfilling. But these have some good features on there, so check that out. All right, reductions in the amount of municipal solid waste by individuals could be accomplished by avoiding products with excess packaging, buying in bulk, reusing both products and the bags used to carry them from the store, buying less or reusing, buying less and using or reusing for longer periods of time, or all of the above. Well, all of these things would reduce solid waste. On to recycling. We can recycle lots and lots of things: aluminum, glass bottles, paper, cardboard, plastic, steel, copper, whatever, all metals really. We can do all kinds of recycling, and we do. We actually do a lot more recycling than we used to. We don't recycle as much plastic as we could. We actually don't recycle as much glass as we could, but we've gotten really a lot better about paper. About 50% of all paper is recycled. And please recall the lumber conversation we had about the lumber industry and managed forests, but also look at this idea of if we do recycle paper, I mean, yes, we want to use some paper, but then we want to recycle it. It matters a lot. Now, it turns out that the first great success for the United States in recycling was aluminum. Most aluminum actually is recycled now, but the cool thing about it is it's so recycled. It's such a big deal in the American psyche about recycling. When you think about a soda can, ooh, we recycle it. It's really the kind of poster child for recycling. It takes 10% of the total cost to recycle an aluminum can as it does to make a new one. And that's very cool. And that's true for lots of recycled products. And so we just want to keep in mind that recycling isn't one of those things that's going to put people out of work. I mean, you have to have people to recycle. It creates jobs in research and development. How do we do this better? It creates jobs in actually managing the products and making new products. So it's a good. All right, so benefits of recycling. I put this in here. It's a cute little flowchart. Read it. We've talked about a lot of this stuff before anyway. All right, so what's the best policy? Should we recycle? Should we reduce? Should we do? All of it, right? It goes back to the idea of the integrated pest management. Integrated anything management is probably the best way, because you have things that have to be dealt with in one way, you have exceptions, you have this, you have that, and so the best thing to do is to integrate it. So what do you do? Raw materials. Well, the first thing that you try and do is reduce how much you're processing and manufacturing. You make your products. Then you start to, hey, can we recycle it? Yes, right? Ooh, can we reuse it was the first one. Can we recycle it? Yes. Can we compost it? Yes. Can we turn it into energy? Yes, right? Can we not? Ooh, no. Then let's do something else with it. Landfill it. Hazardous waste management. Okay. So that brings us to conversation about hazardous waste. What is that? Well, it is anything that falls into these four categories: reactive, corrosive, ignitable, or toxic. You will also see ignitable as flammable, inflammable, or explosive. These are the types of hazardous waste. And the acronym for anything that's hazardous is HAZMAT. HAZMAT. And these are all the little signs that you will see on hazmat things. So first things first, the management of hazardous waste is really important. Hazardous waste in the United States is tracked cradle to grave, which means from the time it's produced, it is actually monitored until the time it is disposed of or made not toxic. CERCLA, which I'll talk about in a second, is the legislation that deals with cleaning up existing hazardous waste. And I'm going to talk about this first because we have a huge problem of lots and lots of hazardous waste being out there that's been improperly disposed of. And this brings us to the idea of the Superfund program. Superfund is a program that is set to designate locations on what's called the National Priorities List, or the NPL, that are brownfields. They are sites, brownfields. They are sites that are contaminated with hazardous waste. There are probably somewhere around 400,000 waste sites in the United States. Some are managed, some aren't, some are on the list, whatever. Some other things that you have are like leaking chemical storage tanks and drums, pesticide dumps, mining waste, right, whatever, all those kinds of things. Old factories, abandoned sites, all of it has to be cleaned up, and it's cleaned up through Superfund. And Superfund is the vehicle in which we can get the most serious sites cleaned up. And here's a map of all of those Superfund sites, the things that are actually on the list. As of 2016, right, January of 2016, there were 1,337 sites officially on the list. And here is this is just a list of a couple as of 2014. So North Dakota actually doesn't have any, but then again, it doesn't have a lot of people or factories. Arkansas has gone up. Illinois had one cleaned up, taken off the list. Then we start looking at, New Jersey. New Jersey has the most in the nation, as does most of the East. If you look at all of these areas where you have these high densities of Superfund lists, you're going to find that they go with industry, right? Most of these sites are current or former industrial sites. And that is because that is where you're going to have the bulk of the hazardous waste stuff. Okay, so Superfund is paid for by taxpayers or polluters or both. It is paid for ideally by the polluters. The answer is both taxpayers and polluters. If you can find the polluters, if they are able to be shown to be responsible. But for example, Exxon still has not paid for the Exxon Valdez spill, right? And it's been decades. So a lot of times this gets locked up in court, and in the meantime, taxpayers pay for it. So you can see it's very expensive to clean all this stuff up. Ideally, the people who make messes clean them up, but in the real world, that's not always true. Now, when we talk about the management of hazardous waste, once you spill hazardous waste into a place, you don't have a lot of choices. One of the things that you can do is dig everything up and replace it. There are some other remediation methods. You can clean up water. There are chemical methods to clean stuff up. But it's a really difficult thing to do that, and it is doable, but it's a very difficult thing. But one of the ways, so physical methods, chemical methods, right? We've talked about that before. We've also talked about that a lot of times, even though you might be able to do a little bit, it's hard, okay? But one of the things that I wanted to point out is there's some cool biological treatments of hazardous chemicals in particular. There are bacteria and fungi that specifically eat certain wastes, and there are plants that will actually absorb certain wastes. And so I've put this in here about phytoremediation. Please be familiar with the advantages and disadvantages of using biologics to clean hazardous waste, but it's a very, very cool thing. Okay, and here are just some examples of various things that you can clean up. Radioactive contaminants, sunflowers are actually great for that. Organic contaminants, look at these beautiful trees. And the great thing about phytoremediation is that you now have a carbon sink. Now, problem, you have to do something with the plants once they become contaminated. A lot of times you have to incinerate them and landfill them. But still, you've had this great opportunity to have a carbon sink. You've had green spaces. It's really good, right? And you can also do metal contaminants too. So pick one of these, know what it cleans up as an example, okay? Now, storage. What if you can't treat it, right? What if you can't treat it? You need to store it. And one of the big ways to do that is a landfill, except unlike the sanitary landfills, this is what we call a secure landfill. It has extra lining, it has extra collection systems, it has an impervious cap on it all the time, and so it's like a super landfill. You can also use something called deep well disposal or deep well injection, right? Same thing. This is where you go into, say, old oil fields or spaces in the rock layers where you can insert stuff in there, and then it is confined from the water. It doesn't contaminate unless there's a leak in some way. And so it sort of takes things and sequesters it. It's like a little sequestration kind of situation. This happens, we do this around here actually. It is suspected that it is this deep well disposal that actually caused the little rash of earthquakes that we had a few years back here. So it's got some interesting problems. And we've talked about that before though, when we had that conversation about does fracking cause earthquakes? It can, but really what causes a lot of earthquakes is this deep well disposal, at least for us, that was the case. All right, so the other thing that you can do with it is surface impoundments. This is an interesting thing because you can store waste indefinitely. You've got all these liners, but this is a real common thing to do, surface impoundments, but the real problem is they're not secure in any way. They're cheap, and that's the difference, right? They're really, really cheap, but they are not good long term and they are not good for security. So those are three big ways to deal with hazardous waste. Okay, there are three priorities in integrated hazardous waste management: produce less waste, put in perpetual storage, and please tell me that you did not choose using chemical weapons or sell to other countries. That is not a good thing. Really, the big thing to do is that once you have them, you can convert them to less hazardous waste. A great way to clean up a hazardous waste is to make it less toxic by having some chemical reaction that will change it into some other product. And that was one of the ways that we can clean up groundwater, for instance, things like that. Yeah. Okay, so I just want to give you one example of a situation that was really important in terms of hazardous waste and bringing hazardous chemicals to the forefront of people's minds, and that is Love Canal. And Love Canal was a canal between the upper and lower Niagara rivers. It was abandoned as a canal in 1920 and turned into a municipal and chemical dump site that was used by, among others, a company called Hooker Chemical Company. They covered the site when they no longer needed it and started to have issues as a company in general. In 1953, they sold it to the city for $1. Let me just tell you, if you can buy that much land for $1, don't. Right, don't. So by the late 50s, the city built 100 homes and one school, this cute little neighborhood, on this site. And this is when things started to go horribly wrong. By the 70s, there were toxic chemicals, really toxic chemicals, percolating up through the soil, drum containers opening, right? People's basements were filling with toxic waste, and people started to get sick. And it was a really, really big deal. And so all of a sudden you had these working class families who were trapped in this neighborhood that was killing them. And so it brings to the forefront the idea of environmental justice and the ethics that go with the environment. They had to really band together and protest and get the government to notice them, to take care of them, because they couldn't do them themselves. They couldn't afford it, and there was no one there to help them. And so environmental justice becomes a thing in the 70s. And essentially what we're talking about is that every citizen has a fundamental human right, regardless of age, race, gender, social class, to have adequate protection from environmental hazards. And it's one of the things that the EPA is supposed to do. Most of these environmental protection regulations come from grassroots campaigns when people say, my neighborhood is killing me. Right? I can't do this. We're not going to do this. And so just to bring in that whole awareness, you want to be careful about understanding every side to an environmental justice issue, because these are things that are easy to derail and turn into other things, right? But essentially, when you have toxic waste coming up through your basement, you need someone to take care of you and help you. And you don't need someone to take care of you, but you need someone to help you make sure that that doesn't happen to anyone else. And the way to do that is regulation in that case. And so there you go. All right, we'll talk about this more in class, by the way. Which of the following is not a potential source of hazardous waste in your home, right? Speaking of toxic waste in your home, most of you hopefully do not have pools of toxic waste in your basement, but you do have toxic waste in your house. Well, it seems like it's obvious that it would be something that you would use, like nail polish on you, but we know that nail polish is toxic. Flea powder is a pesticide. Batteries, we know, have all sorts of toxic things in them. But it turns out that Windex, a cleaner, right, Windex, actually is not toxic. There is no source of hazardous waste in Windex. There is, however, an artist paint. So go through your house at some point if you want to, and just give a little look-see and see what you have in your house that is actually dangerous. Okay, so dealing with materials, use some waste, right? our first priority is waste prevention, right? In terms of changing processes so we're not using them, using less harmful products, actually reducing the amount of waste, right? The next thing is to reuse, repair, recycle, compost, right? And then the last priority is to actually manage what you do have. But the first two are about source reduction. The last one is about managing what you've got. Then I have also put in here for you legislation. The general waste legislation is the Pollution Prevention Act. Basically, you want to reduce prevention. Anything that can't be prevented should be recycled when it can, okay? And then legislation, CERCLA is what I talked about, the Comprehensive Environmental Response Compensation and Liability Act, right? That's Superfund. RCRA, the Resource Conservation and Recovery Act, this is specifically that cradle to grave tracking that I was talking about. Toxic Substances Control Act, this is about what can come into the country, what can be manufactured. And then the Federal Hazardous Substances Act, this is what requires all of your products to have all of your household products to have cautionary labels on them. Then you have the Federal Food, Drug, and Cosmetic Act, which says that you can't have things that are toxic, that cause cancer. And then FIFRA, which is the Federal Insecticide, Fungicide, and Rodenticide Act. We've talked a little bit about that when we talked about pesticides. And then asbestos, hazard and emergency response. I put that in there not because asbestos is such a huge problem anymore, but because it does affect schools, and you are in a school and it comes up. All right, so some people have gotten around the system by shipping waste overseas, and we have actually talked about this before in class, so just review your notes on that. Okay, this one was a little bit longer than normal, and I'm sorry about that, but we had two big things to talk about. If you have any questions, please ask me in class, and I will see you next time. Thanks for listening.